Okay, so here we go. Number 11. It says, in figure A, a sled moves in a negative x direction at a constant speed of vs. So you've got this little sled or cart or whatever, and it's moving this way at a speed of vs, as in velocity of the sled. I guess technically that's going to be relative to the ground, right? Okay? Now, we're going to launch a ball out of it with a velocity of vox and voy relative to the sled. And it doesn't tell you what direction it's fired, whether it's being fired forward or backward. Okay? It turns out it's got to be being fired backwards, and I'll explain how we know that in a minute. Okay? I did not know this when I first read the problem. I had to analyze the graph to figure out why. Okay? So, I'm going to draw it that way, and I'll explain how I knew it had to be drawn that way in a minute. Okay? So, here is the velocity of the ball of ice. What do they call it? They just call it B, right? So here's the velocity of the ball of ice relative to the sled initially. Okay? And then the two components of that, the problem has called Vox and Voy. So both of these components are relative to the sled. Okay? And if you read the problem, it says that pretty explicitly. Good? All right? So, the graph compares the velocity of the sled to the displacement of the ball relative to the ground, right? So the horizontal or the vertical axis of my graph is the displacement of the ball relative to the ground, and the horizontal axis is the velocity of the sled. And then the graph looks something like this, right? Follow? Okay. So, it seems to me like so what are the two obvious points to pick? I shouldn't say obvious, that's...
Intercept at 0.
But yeah, look at your intercepts, right? Okay? So what this point is telling me, what the blue point is telling me is this. If the velocity of the sled is 0, then the displacement of the ball relative to the ground is 40 meters. And I got the 40 meters by reading the graph. Cool. So the 40 meters is, it's this number right here, 40. Follow? All right. So that still doesn't really help me, right? Because I don't know, what it's telling me is that if the sled isn't moving and I launched the ball with this velocity, it's going to go 40 meters. But I don't know anything about these two components, so that doesn't really help me too much yet. So does everybody understand what that tells us and why it sort of doesn't help me too much yet?
Yeah.
All right, now, let's take a look at this point. What this point tells me is this. That point is telling me that if the velocity of the sled is 10 meters a second, negative, I guess, right, because it's going to the left, then the displacement of the ball relative to the ground is 0. So what that's saying is, relative to the ground, the ball went straight up and straight down. That is huge. That piece of information is colossal. Automatically, I know one of the three sides of my triangle based on that. So think about it. The sled is moving this way, right? Sled's moving this way. If the projectile gets fired straight up in the air, then the projectile is going to have the same horizontal displacement as the sled, right? So if the sled is moving this way, and I want it to not go this way, I have to fire it backwards. With what horizontal velocity? Equal but opposite to the sled's velocity, right?
Yeah.
Oh. So if the sled is going that way at 10 meters a second, but it doesn't move, that means this must be positive 10 meters a second. Does that make sense, you guys?
Yeah.
Yes. Was there something this tricky on the test?
I'm trying really hard to write my tests, so they're a comparable difficulty level with what you'd see on the AP test. A lot of this stuff is stuff that I think will help you get better at physics, but it wouldn't necessarily be on the test.
So
Know what I
we
mean?
don't- Okay.
So,
This is good.
yeah, this is totally tricky. Yes.
So, when I was reading this question, I thought that like, this was like a one continuous thing, like you were shooting the ball and like the graph was charting it like over a period of time. I didn't think that it was like different trials,
Right.
like almost. And so I got like completely tripped up on that, so like,
So your latter explanation is correct. It's sort of different trials. Your first explanation kind of doesn't make sense.
right,
Because once the projectile gets launched, changing the velocity of the sled doesn't matter. Right? Because the projectile's already up in the air.
yeah, I guess I just really did not understand this question.
Okay. But does this process make sense? All right, great. So, oh, cool. So I just used this green point and found out a whole bunch of valuable information. Now let's use the blue point. So what the blue point is telling me is if the sled is not moving and I launch the projectile, it'll go 40 meters while it's in the air. So, how fast is the ball moving that way horizontally if the sled's not moving? 10 meters a second. How long is it going to take to go 40 meters? 4 seconds. Ah! Does that depend on how fast the sled is moving? No, because my vertical velocity is what determines the time in the air. Right? So no matter how fast the sled is moving, it's going to be in the air. The ball is going to be in the air for 4 seconds. Follow? Evan? Yep. So if I can, suppose I can consistently throw this pen up in the air at exactly that same velocity and actually catch it like a real human being. Okay? Okay? So, 1, 2. God bless it. I'm going to use a prayer. Less pointy. All right. 1, 2. Right? 1, 2. Even if I'm walking sideways, 1, 2. Right? So the horizontal motion of the sled does nothing to affect how long the ball is in the air for. Good?
But how can you find the number?
Sorry?
How can you find the 4 seconds number?
Well, because what I know is it's moving horizontally at 10 meters a second. And if the sled isn't moving, then it's going to go 40 meters. So how long would it take at 10 meters a second to go 40 meters? 4 seconds, right?
Yeah.
Does that make sense?
Yes, I feel
It's not obvious. This is complicated. But does that make sense, you guys? All right, so now what I know is this. I know my projectile is going to go, and it's going to land after 4 seconds, which means it hits the top after 2 seconds. What's the vertical velocity here? 0. So 2 seconds before that, the vertical velocity must be 2 times 9.8, which is 19.6.
That's so wild.
Hang on. Give me like 10 seconds. Oh. Stop counting. It's going to increase the time I need to absorb this.
Right? So look, I know the ball's got to be in the air for 4 seconds. Is everybody okay with how I got there? All right. So now the question is, what does the vertical velocity need to be to make it be in the air for 4 seconds? Well, I know the velocity decreases at a rate of 9.8. Right? So in the course of the time it's in the air, the velocity's got to decrease by, what, 39.2, right? 9.8 times 4. Right? Half of that's on the way up, half of it's on the way down. Matt, here, do you want me to do the equation? Here's the equation. It's this. Oops. So if my time is 2 seconds, I don't know what VOY is. I know my acceleration is negative 9.8 meters a second squared. What's my VFY, you guys? At the end of 2 seconds? 0. You're right, after 4 seconds. That would have been good too. Cool? So now you just use, oops. So now you just use A equals VF minus VI over T and solve for VI. Follow? All right, so this trick trick, you guys, is a thing that you absolutely have to know for projectiles. If you know how long a projectile is in the air, you automatically, well, assuming it starts and ends at the same height, you automatically know your VIY. Okay, yeah, this is tricky. It's tricky for sure. Yes, 4.3 is easier. Yeah, so I think the other thing I'm going to do next year is I'm going to, yeah, well, anyway, okay, are we good?
Yeah.
All right, so last one is 14. Do we have time to do 14?
Yes. Or you want to do the trick?
Oh, all right, so hold on, so real quick. So that's a, oh, are you guys good with B and C? For 11B and C? Let's do 11B and C real fast. And they are fast. So 11B says the ball's displacement can also be measured. Assume the sled's velocity is not changed when the ball is shot. What is the displacement of the ball, relative to the sled, when Vs is 5 meters a second? Right, here's why I put a smiley face on it.
Because you don't want to
Why am I dumb? My brain just stopped here. Yes.
No, that's B. The graph is.
Right. All right, so to do 11B, here's what I know. Based on the graph, I know that if Vs is 5, then the displacement of the ball relative to the ground is 20. Right?
Yeah.
Okay. So, how do I find the displacement of the ball relative to the sled? Well, displacement of the ball relative to the sled is the same as the displacement of the ball relative to the ground plus the displacement of the ground relative to the sled, right? Oops. I'm making this more complicated than I need to because I haven't had enough coffee today. So this is the displacement of the ball relative to the ground minus the displacement of the sled relative to the ground. So, displacement of the ball relative to the ground is 20 meters, right?
Yep.
Minus how far will the sled go in that time? That was weird. How long will the sled go? How far will the sled go is what I'm doing a rotten job of asking. How long is the ball in the air for?
4 seconds.
4 seconds. And if the velocity of the sled is 5, it's going to go 20 meters. What's 20 minus 20? 0. So that means the ball is going to land right back on the sled.
Can you add the velocity vectors to like
Yeah.
-5?
Yeah. It was given to you in the problem. Cool?
Yes.
What's wrong, Maggie? How did I get the 20? This one? Because I know the ball's in the air for 4 seconds, and the problem tells you the sled's moving at 5 meters a second.
I didn't know it was like.
But then do we notice the horizontal velocity of the ball is?
Sorry?
I'm confused as to how you got that the ball would move 20 meters in 4 seconds. Is the horizontal velocity of the ball equal to 5 meters per second as well?
Wait a minute. There's something wrong here. I'm missing a negative sign somewhere. It can't be 0. The only way it would be 0 is if the sled was shot, or if the ball was shot straight up in the air. What am I missing? The sled's moving that way. What did I miss here?
Aren't they going in opposite directions?
Isn't the velocity of the sled technically negative, so wouldn't it be
Yes, minus negative. Thank you. That's what I'm missing. So that gives you 40 meters. There we go. Sorry about that. That makes way more sense.
So what about C then?
So part C, you guys are going to do the same way, except here we did 5 times 4. In part C, you're going to do 15 times 4. Good? All right. Sorry about that. I knew something was wrong there. All right. So that is that. We didn't get to 14. I really think 14 is not that big of an issue. So use the time over the weekend to work on projectiles. What did we say? We've got 4.3a is due on Monday. Tuesday we'll do circular motion notes, and then you've got a worksheet due both Thursday and Friday. All right. So. Are we feeling better about this, you guys?
Somewhat.
No, somewhat. Yes, I see some nods. If you're in the no camp, if you're in the